Hello and welcome to your preview of Training to Go modules presented by Technical Sales and Consulting. At the end of the preview, we will provide how to access more information about our training products. Thanks for visiting, and we hope you enjoy the preview. Electrical safety is essential in any environment where electricity is present, and adherence to established clearance standards is essential to mitigate risk and ensure the well-being of individuals and the integrity of the equipment. Critical aspects of these standards are the minimum electrical clearance of live parts, electrical equipment working clearances, minimum electrical clearance of live parts. This is the principle that dictates the necessary space between live electrical components to prevent arcing and potential hazards. As per widely recognized guidelines, a minimum clearance of 1 inch per 1,000 volts is often observed, ensuring that the distance between the energized conductors is sufficient to prevent electrical discharge or unattended contact. Adhering to these standards minimizes the risk of electrical shock, insulation breakdown, and fire hazards, safeguarding both personnel and equipment. Electrical equipment working clearances, in addition to the clearance between the live parts, it is essential to maintain adequate working space around the electrical equipment to facilitate the safe operation, maintenance, and inspection. Standards such as those outlined in the National Electrical Code provide specific requirements for the minimum distance between electrical equipment, walls, structures, and other obstructions. By ensuring sufficient working clearances, personnel can perform tasks such as troubleshooting, servicing, and repair safely and efficiently, reducing the likelihood of accidents or injuries. In summary, ensuring compliance with minimal electrical clearances for live parts, equipment working spaces, is fundamental to promoting electrical safety in various settings. By adhering to established standards and regulations, individuals and organizations can mitigate risk, prevent accidents, and create safer environments where electricity is present. When we talk about electrical clearances, what do we mean? Well, when an item is shipped from the factory, it is designed with the required standards applied. The concerns involved are phase-to-phase clearances and phase-to-ground. What happens after the product is delivered concerns all technicians. If connections to switchgear take place in the field, the proper clearances must be maintained. Any cable or bus connections must maintain the proper clearances. Now, what is the proper clearance? As mentioned, a widely accepted rule of thumb mandates a minimum distance of 1 inch for every 1,000 volts of electrical potential. This principle serves as a foundational safeguard meticulously calculated to mitigate the risk of electrical discharge and ensure the integrity of electrical systems. The rule of thumb prescribing 1 inch of clearance per 1,000 volts is a widely recognized guideline in the field of electrical engineering, particularly in the design and installation of electrical systems. While it is extensively applied in practice, it is important to note that specific standards and regulations may vary depending on regional codes and industry practices. If we examine the NEC Table 495.24 from the National Electrical Code of 2023, we can see where the rule of thumb is derived. The table shows a 2.4 to 4.16 kV rating. If we follow it across, we can see that the indoor phase-to-phase clearance is 4.5 inches. If we divide the 4.16 by the 4.5 inch clearance, the result is approximately 1.08 per 1,000 volts. Although this is not exactly 1 inch, it may provide some support to the rule of thumb spacing. Notice how the spacing increases as the voltage increases. This table provides comprehensive guidance for minimum electrical clearances when reconditioning electrical equipment. In essence, the principle of minimum electrical clearances serves as a cornerstone of principles for every electrical technician, embodying the commitment to safety and excellence. Electricians need to have proper access to electrical equipment in order to properly operate and service them. Cluttered areas not only restrict access, but they could ignite under abnormal conditions from electrical equipment. Equipment rooms need to be clean and clear of everything. If your room looks like this, you're putting your building at risk and it needs to be cleaned up. Tight conditions like this pose unsafe conditions for technicians. Proper working space is required by the NEC. Let's spend some time examining these regulations. The code references both working clearance and dedicated equipment space. We'll go over both terms. NEC Article 110.26a covers working space and applies to equipment at 600 volts nominal or less to ground and likely to require examination, adjustment, servicing, or maintenance while energized. These include switchboards, switchgear, motor control centers, panel boards, disconnect switches, circuit breakers, controls, and transformers. Table 110.26a1 shows the parameters involved with allowing the proper working space. The first column shows the nominal voltage to ground. The second column shows the typical system voltage. The next three columns represent specific conditions based on the location of the equipment. So let's jump into this to illustrate and explain the three conditions by using an example of electrical equipment 151 volts to 600 volts to ground on a 480 volts/277 volt system. Condition 1 is an installation where the opposite wall is composed of wood or insulated drywall as seen here. The required distance is 3 feet 0 inches. Condition 2 is the same as condition 1 except the opposite wall is concrete or steel. In this instance, the space is 3 feet 6 inches or 3.5 feet. Condition 3 is when the electrical equipment is lined up across from each other. In this instance, the required space is 4 feet 0 inches. The table can also be followed easily for other voltages and conditions. Now we'll discuss dedicated space. Clear space is also required above specific types of electrical equipment that are designed to have a large number of conduits or cables entering the enclosure. Subparagraph 110.26f establishes this requirement for switchboards, panel boards, and motor control center. A clear space equal to the width and depth of the equipment must extend 6 feet above the top of the equipment or to the bottom of the structural ceiling, whichever is lower. No piping, ductwork, or other equipment foreign to the electrical installation is permitted in this space. If piping or ductwork is located above this space, protection from condensation and leaks must be provided. Note that fire protection sprinkler piping is permitted within the dedicated space. If the operating voltage of the equipment exceeds 600 volts, subparagraph 110.34f adds a requirement that the piping or ductwork not be located in the vicinity of the equipment. This wording leaves room for interpretation, but usually is recommended keeping all unnecessary piping and ductwork outside of the electrical rooms with equipment over 600 volts. Taken together, these requirements for working in dedicated space should provide electrical installations that can be safely maintained and accommodate the installation of future circuits. Keeping them in mind when laying out equipment rooms should reduce the number of unpleasant surprises and changes. Hi, we hope you enjoyed a sample video of our online e-learning module. This clip is from one of our many available modules. We're always working on new modules, but here is the current list of developed lessons. Outlines, pricing, previews, and requests for information are available at trainingtogo.net. Let our Training to Go programs train your people while you run your business.